Okay, let's see how you're doing. So even if you're not done, will you just come with me to number 1? What could we say x is equal to in number 1? What's x equal to in number 1? Sylvia? 18. Can you tell me how you decided that, Sylvia? What did you decide that x is 18?
If you take 25 minus 7, you get 18.
Yeah. So if you think like this, if you take the 25 and you subtract the 7 from it, that's what should be left over. That would, if you added it back to 7, you would get 25. Okay, I'm going to quick calibrate my board here, and then we'll be ready to move on. So anybody have questions about that one? Number 2 then. Who wants to give us what b is equal to in number 2? What is b equal to? Caden?
82.
82, Caden says. Okay, do we agree with him? Okay, Caden, how did you decide that?
I took 125 minus 43.
Okay, and 125 minus 43 gives us the 82, because if we added 82 back to the 43, it should result in 125, right? Number 3, what is z? What is z in number 3? Paikia? 6. Okay, can you justify why it should be 6?
I just thought of multiplication.
Okay, what would we multiply?
3 times 6.
Yeah, if you can think of it as multiplication also, if we took 3 times 6, it would get us the 18. So b has to be equal to 6. Okay, number 4. Caden?
16.
16. Okay, why is it 16? Give me your reasoning.
Minus 16.
Are you changing your mind?
Mm-hmm.
It would be 16 if the operation was what?
Adding.
Subtracting?
Or subtract.
Yeah, if it was subtracting, then that's what it would be. Okay, so we're going to let somebody else override you, okay? Sierra?
63.
63, you say. Okay, so 63. Why is it 63?
Because if you do 63 divided by 9 equals 7.
Okay,
Because how I figured that out, I times.
so you can actually use the multiplication. You can say, well, if you take the 7 times the 9, you would get 63. So 63 divided by 9 does have to result in 7, doesn't it? Okay, number 5, what would that be? Class? 100. 400 take away 300 is y. That makes y 100. How about number 6? Number 6, what would that one be? Danny? 195, I think I heard. Okay, and tell me why. Okay, so if you add the 2 to the 195, it should take you back to 197. Okay, good. So we all can find the missing piece, the piece that the variable is standing in for. Okay, well now in this next one, we're going to do some substitution. It says substitute the values for the variables and solve. I don't call it solving, I call it evaluating, but this one calls it that. So we are going to take n plus 1, and we're going to substitute in for n. We're going to put the 7 because it says if n equals 7, so we're supposed to substitute. So 7 plus 1. And what is 7 plus 1?
8.
It's 8. So the value of n plus 1, substituting 7 in for n, we end up with 8. Okay? Well then in this next one, it says if 2 plus x equals 8, what is the value of x? Well, that looks like what we were just doing up in activity 1, correct? What would x be? 6. And how do we reason through that? That it's 6. How do we reason through that? Kira?
8 minus 2.
8 minus 2 equals 6. In other words, if you take the 2 away from the 8, that will give you what you should add back to the 2 to get the 8. Okay, good. How about number 3? What is the value of 4 plus y if y equals 18. So in other words, they're saying now there's no equation there. You're not trying to find the missing piece. You're being told you're supposed to use y is equal to 18. So you're going to substitute in, and what do we get? Carly? 22. 4 plus 18 is 22. So the expression 4 plus y is equal to 22 when they tell us that y should be 18. Cheyenne? Okay, so you're saying that what? We should have added 2 to 8? 8 plus 2. And what would 8 plus 2 be? That would be 10. So then so basically this is kind of like what we're doing in this next one, number 3, where we're substituting. If we put 10 in for x, would 2 plus 10 be equal to 8? No, that's equal to 12, isn't it? And 12 doesn't equal 8. So we are actually looking for, so we're looking for the number that if you add it to 2, it will get you to 8. And we can find that by subtracting that 2 from the 8, and that says, oh, well, there's 6 left over to add to the 2. Does that help? Okay. How about number 4? Solve, it says, evaluate, I'm going to call it, n minus 8 if n is 17. What are we going to do, class?
17 minus 8.
17 minus 8. 17 take away 8 is what?
9.
9. Our answer is 9. Okay, you do the last 2 for me. 5 and 6. Show the substitution step. Don't just come up with an answer without substituting first. Okay, and number 5. If z is equal to 25, what's z divided by 5? 5. 25 divided by 5, putting 25 in for that z, we can say it is equal to 5. How about our number 6? If m divided by 9 is our expression, and we're supposed to put an 81 in for m, what are we going to get as our answer? Kelia? 9. 81 divided by 9 is another 9. In other words, 9 times 9 is? 81. Okay. So any questions? Further questions on this before we move on? The next thing they want us to do? No? Okay. And let's move on to the next thing, which is in the Apply Skills section, we are going to, it says, write the ratio for each problem. So we should always start by reading the directions, right? Write the ratio for each problem in 3 different ways. Did we learn 3 ways yesterday? Okay. Then circle the correct answer to the question, and the question is going to be, is it a part-to-part relationship or a part-to-whole relationship? So they have the example there. A cookie recipe calls for a cup of sugar and 2 cups of flour. What is the ratio of sugar to flour? What did I say is one of the most important things you have to remember with ratios? What matters? What matters? Switch with an O. Order matters. Order matters. So here, what do I mean by order? It says ratio of sugar comes first, flour comes second. So in this one, it was 1 cup of sugar. So the 1 comes first in our ratios. 2 cups of flour, the 2 is the other part of our ratio. And why is this a part-to-part relationship? Why is it a part-to-part? How would you justify to somebody that a cup of flour, or excuse me, a cup of sugar compared to 2 cups of flour is a part-to-part relationship in a cookie recipe? Or tell me how you can make it a part to a total then, a part to a whole. How could you do that? Nobody can tell me? Well, does a cookie recipe, first of all, have anything more in it besides sugar and flour? No? You guys have never made cookies, have you?
Yeah, we have,
Have you?
Yes.
in facts.
Well, then what do you think? Does a cookie recipe have more than sugar and flour? Those are regular made cookies. Well, yes, it's gotta have some sort of like butter maybe, or, and some
Okay.
eggs and maybe some, vanilla, maybe some chocolate chips, maybe, there's all kinds of things that go into cookies depending on what kind you're making. So if we were gonna compare how many cups of sugar there are to how many cups of total ingredients there are in the cookies, then that would be a part to whole. But we're comparing one part of the cookie recipe to another part of the cookie recipe, so that makes it a part-to-part relationship, okay? So let's do this next one. Aaron makes light blue paint. He wants to have light blue paint. He mixes 2 quarts of blue paint with 1 quart of white paint. What is the ratio of, oh, this is really important, ratio of blue paint to white paint? Well, we're gonna write that. The ratio of blue paint, can't write real big. The ratio of blue paint to red paint, order, matter, or white paint, not red. I don't know where red came from, it's my color of my pen. Blue and red would not make light blue. What color would it make? Purple. Okay. Blue paint to white paint, order matters. Okay, now we're supposed to write that the ratio of the 3 different ways that we can. So how many quarts of blue do we have? 2. Teal, how many quarts of white? 1. So for every 2 quarts of blue paint, he needs 1 quart of white paint. Okay. We can also write it 2:1. We could also write it, what's our last way? A fraction, at least it looks like a fraction, 2/1. Okay? What kind of a relationship do we have here? Part to part or part to whole? Part to part or part to whole? Blue paint and white paint, trying to make light blue paint. We have a part to part or a part to whole relationship.
Part to
A what? A part to part? How many of you want to agree on this table up here? They say part to part. You all should be agreeing with them. Now you're going to raise your hands, aren't you? It's a part to part relationship. What would make it a part to whole?
If we knew how much paint they had.
If we knew how much paint they were going to have to go buy altogether, and we were comparing the blue part to the total amount of paint, or the white part to the total amount of paint, then we would have a part to whole. But here they're saying you got to buy 2 quarts of blue, and for every 2 quarts of blue, you're going to buy 1 quart of white. So what's that total? 3. So if that's all he buys, he would have a total of 3 quarts of paint. So if we were going to compare the blue paint, the 2 quarts of blue paint, to the total amount of paint, it would be 2 to, listen, everybody, tune in. If we were going to compare the 2 quarts of blue paint to the total amount of paint, it would be 2 to
3.
3, because 2 plus 1 is 3, the total of 3. Okay, we have to catch this. We have to be able to understand this, okay? So questions? Okay, you try the next one on your own then. You saw what we did in the last one. Try this one on your own. are we comparing? What numbers in there describing who we were describing what we were comparing? Okay, first thing I'm gonna ask is, did you take the time to underline this? If you didn't, do it now. What are we comparing? We're comparing the ratio of cats. Well, all you had to do then was copy it down to here. Ratio of cats to total pets. Ratio of cats to total pets. So you always want to say to yourself, what am I comparing, and in what order am I comparing it? We are comparing the cats, number of cats there are, to the total number of pets there are. Well, it says there are how many cats? 14. T.O., how many total pets? 35. We didn't even have to do any calculating. We just had to look at the information, didn't we? 14, colon, 35. 14 over 35, okay? Part-to-part relationship or part-to-whole relationship? Part-to-part, how about, Anna? Part-to-whole. What gave away the fact that this was a part-to-whole? What gave that away? What word? Yeah, the word total. Yeah, total pets, total. That's the whole, okay? Now, this is where I need to stop then and make sure that we understand, we had this in our notes yesterday, that fractions, are you with me here? Fractions are always a part-to-whole relationship. Fractions are never a what? Part-to-part relationship. Ratios are sometimes a part-to-part relationship. Ratios are sometimes a part-to-whole relationship. So is this 2 to 1 here, is this a fraction in that first one? Is it a fraction? No, it's written like a fraction, but is it truly a fraction?
No.
No, because it's a part-to-part. Fractions cannot be part-to-part relationships. Fractions cannot be part-to-part relationships, okay? So we have to make sure that we understand the difference. How about this one? Can this be called a fraction then? Can our 14/35 be called a fraction? Yes, that one can be called a fraction because it is a part-to-whole relationship. So fractions sometimes are written, like a ratio can sometimes be called a fraction and other times it can't. It just has to be called a comparison. Okay, let's go to the next page where we're going to do some more of these. 14 cats, 15 dogs in the pet store. What is the ratio of cats to dogs? The first thing we're going to do is what? Underline what we're comparing. And then it's so easy to fill it in, isn't it? The ratio of what? Cats to dogs. What does that ratio look like? 14, teal, 15. 14, colon, which while we read that, we don't say 14 colon 15, we're still reading it 14 to 15. And then we have 14 over 15, and again, we don't read that 14 over 15, we read that 14 to 15. It's just another way to write it, another way to display it. Okay, what kind of relationship? Part to part. Okay? There were no totals going on here, were there? No. So is 14 15ths a fraction? Can it be called a fraction? 14 15ths? No? Why not? It's a part-to-part relationship, so fractions are not part-to-part relationships, they are part-to-whole Okay. Let's quickly do these last two so that we can move on and get time to do the last page that we have. We have a ratio of green marbles to total marbles. So I'll just let you write, we may not have enough room to write the marbles in there, so let's just say green to total. How appropriate I'm using a green marker, huh? Okay. So what are we gonna write? Which one comes first every time? 35. And the other one is 60. Did we have to do any calculating to get it? Do we have to sometimes? Sometimes we do, depending on what they want us to compare, what kind of information they gave us. Part to part, part to whole. Part to whole. What gave it away again?
Total.
Yep, total, right there. That gives it away, doesn't it? Can 35/60ths be called a fraction then? Yes, because it is a part to whole relationship. 35/60ths can be written as it is considered a fraction. Okay, and the last one. We're comparing what? Green marbles to blue marbles. So ratio of green to blue. Which one comes first? 35 or 10? 35. Okay. And is this a part to part or a part to whole? It's a part to part. Okay, now I just want to stop for just a second and talk about how that can actually be renamed. Because here's what this one really says. For every 35 green marbles in this bag, so envision 35 green marbles in the bag, there are 10 blue ones. So we have 35 green marbles, 10 blue in this bag. Could those be separated into equal groups of something? And then we could say a smaller comparison to make. Could you divide 35 green marbles into equal groups that blue marbles could also be divided into those equal groups of? Are 35 and 10 then, in other words, multiples of some number? Are both of them multiples of some number?
Yes.
What number is that? 5. Yeah, it's 5. So couldn't this also be renamed? How many 5s can you take out of 35? 7. How many 5s can you take out of 10, Delia? 2. So now what is that ratio saying it as? 35 marbles that are green compared to 10 marbles that are blue is the same as 7 green and 2 blue. So we have to understand that there are different names for the ratios also. Because that's what we're going to start moving into next year. Okay? And you've already done some work with it and don't even realize it. Let's go on to this last page then. Are we on the last page or there's a couple more? One more after this. Oh, we gotta move then. Okay. Use the table to solve the following problems and tell whether the relationship is part to part or part to whole. Okay, the ratio of boys to girls. Well, that's the first important thing right there. And so this is, and it's 2 to 4. So the 2 is representing boys or girls? Boys. And the 4 is representing girls. So I'm going to go to my table when I make my table and I'm going to say every 2 boys, so my row of boys is going to go up by 2's. Okay, we've been doing this already. And 4 girls, so when there are 2 boys, there are 4 girls. So our girls row is going to go up by 4's. Okay, this is kind of starting to look like activity 3 on that worksheet you just got back. here's what I want everyone to do first before we even move on. I want us to say, to get from the top row to the bottom row, what do you have to do to the top number to get the bottom number? What do you have to do to 2 to get 4, 4 to get 8? No, you don't divide. 2, you multiply it by 2. 2 times, so if you're starting on the top, you multiply times 2. 2 times 2, 4. 4 times 2, 8. 6 times 2, 12. If you start on the bottom and work up to the top, what do? You divide by 2. So at one end, you're going to be multiplying. At another end, you're going to be dividing. We don't know which one we're going to be doing at which end, but we should always be multiplying or dividing by the same number within the table. So that's the first thing I want to see after you make your table. Now, we'll go and look at the question that says, there are 20 girls. How many boys? So let's go to our table and let's circle where there are 20 girls. Well, they're in the bottom, so it's right here, isn't it? So how many boys are there? 10 boys, and that's what our table says. Now we're going to show, what if we didn't have the table? How could we figure out how many boys there would be? How can we figure out that 10? So what could we actually do? Kira?
2 divided by 20 divided by 10.
No, 20 divided by what again? We're in the bottom row and we divide by 2. 20 divided by 2, we know the number in the bottom row. In this table, you going up, you divide by 2. So that problem verifies that we have the correct number of boys. Every time you have the number of girls, if you divide them by 2, that will tell you how many boys there will be. So here's our answer with our division problem to support it. Questions? Okay, let's try the pigs and goats one then. Ratio of pigs to goats. 1 to 5. 1 what? 1 pig, 5 goats. Okay, so in the table, wherever we make our row of pigs, the pigs are going to start at 1 and go up by 1. In our table, the row of goats is going to start at 5 and go up by 5s. Okay. And what's the next thing we're going to do? Figure out the multiplying and dividing that's going on in our table. So to go from top to bottom in this table, what do? From 1 to 5, 2 to 10, 3 to 15? No, what do you do to 1 to get 5? You times it by
2.
5. You multiply by 5. There are 5 times as many goats as there are pigs. And when you're going from the bottom up, you know how many goats there are, and you want to figure out how many pigs there are. You divide by 5. Okay. So that's the first thing you always want to do before you even now start trying to answer the question. So then the question is, how many goats are there? Or we know how many goats there are, and we're supposed to figure out how many pigs when there are 15 goats. So our table shows us, we go to 15 goats, goats are in the bottom. Our table shows us that there are how many pigs? There are 15 goats and 3 pigs, okay? There are 3 pigs. There's our answer. They call this vertical strategy. In other words, what do we have to do to that 15 in the bottom to get our 3 pigs in the top? Harley? Divide. So tell me the division problem. 15 divided by 5. 15's in the bottom row. We're going up, so we divide by 5. We get 3. So I'm showing you also right now, those of you who have activity 3 to finish on assignment number 22. That's really what's going on here, okay? But the X's and O's problems. So questions? Why don't you try the next one on your own? Do it. Do the next one on your own for me. Okay, anybody know how many pigs there are? How many pigs are there? How many pigs are there? Ikea? 5 pigs. Okay, somebody else support that with a multiplication or a division problem for us. Sylvia?
50 divided by 10 plus 5.
Okay, so every time in these particular problems, we're moving from the bottom up. Now, you have to make sure that you pay attention to your table and the way the ratio was set up, okay? Within these. Now, we forgot to do one thing in all of these, and that is decide what kind of relationships there are, okay? So let's go back and let's look at number 1. Is that a part-to-part relationship or a part-to-whole? Boys to girls?
Part
Part to part, okay? So we're going to say somewhere here, part to part. That's also what they wanted from us. Not only to find the missing number, but what type of relationship is shown in this ratio. Okay, how about number 2? Pigs and goats. Part to part again. And how about number 3? Part to whole this time. Part to whole. I won't make you write out the word relationship every time. Let's just write out the part to part, part to whole. Okay? We're not going to have time to do the other two because I want to get your homework out to you and explain it to you. So we're just going to stop there. Do you think you know how to do it? You got this? You got this? Okay. Okay, let me get your homework out to you, and then I need you just paying attention. Why don't you get out a sheet of loosely paper, though, please, so that we have it out and we can talk about what you can show on that. So get out loosely, and when you get your worksheet, put your name up and the assignment number, and also put that on your loosely. Okay, so your name, and this is assignment number 24, both on your loose leaf and on your worksheet, on both places. one side, ratio wording. This one you don't have to do anything on loosely for on this side, okay? So let's look at number 1 and number 2, okay? Number 1, for every 2 males birds in a bird cage, there are 5 females. I mean, I should say male birds, really, but okay. For every 2 male birds in a bird cage, there are 5 females. What is the ratio of males to females? Underline that. Ratio of males to females. You want to make sure that you set it up in that order. So what would our ratio be? Number 1, we're going to put it over on the line. Number 1, it is, what is it? 2 to 5. Let's use the colon way, everybody, okay? 2 to 5. Let's use the colon to show our 2. Okay, so pay really close attention to order. It isn't always necessarily going to be, they might try and, trick you. Okay, let's look at number 2. At the store, the ratio of books sold to movies sold was 8 to 2. What do you suppose you should underline? Ratio of books sold to movies sold. So the 8 is representing what? Books. So we're going to fill in these blanks, and we're going to do it over on the. You can do it there, and then we'll just move it to the answer lines over here. So in number 2, for every how many books sold? 8. There were how many movies sold? 2. So they're just getting you right there to think like. And then come over here to the answer line and put that 8 and that 2. They're just trying to get you to think about what is that ratio telling us, okay? So this side you don't have to show any work on this. Let's go to the back side. A classroom had 35 glue sticks. If the ratio of glue sticks to glue bottles was 5 to 2, how many glue bottles did the classroom have? You are going to need to make tables for these, okay? So put that note at the top of this page. Make tables on loose leaf. Make tables on loose leaf. Now, you're not always going to have to make a table because not always are you solving. So let's circle the ones you do. 1, 2, 4, 5, 7, 8, and 10. 1, 2, what was the next one? 4, 5, 7, 8, and 10. Those are the ones that you're going to need to make tables on loose leaf for to help you answer those problems, okay? Anybody need those repeated? One last time. Okay, use the notes that we used in class today, especially on the back side here, that's what those last 3 problems we just did, use those to help you. And for those of you who need to finish activity 3, use those to help you. Okay, so then I have, okay, so I'm just going to leave it with me and I'll have to correct it. And Danny, I'll have to correct yours too, and Tyler, we have to make a plan here. Can you be here at 7? Okay, 7 a.m. door 2. You and me. He has 5 problems to finish up. Stay here with me, Tyler. Can you stay with me?
With the regular comment, 7
Stay with her. Okay, I'm going to send it with you and have him do it after school.
So should we do it after school and not?
He should, because he should be getting his other homework done for his study. So we don't have the same issue tomorrow.
Okay.
Okay. And then Mrs. Allen, I will let you make the call. It's Mrs. Allen's work done tomorrow. And he doesn't have any other homework to work on. During study hall, then I'm not gonna make you stay out here. You can have him do it, but his other homework is to be done. I only make you. Okay. There isn't a candy I don't like, Paul, so you got it. Thank you. I just plain love candy. So, you're doing awesome.
Oh, candy corn is my comfort.
I love candy corn too. Wow. So you